to explore another way of solving problems involving percent, and instead of using the percent proportion, we will be looking at the percent equation. So this was the proportion that we used yesterday, and now we have the equation, and we talked about how they removed the 100 that was part of the proportion and reworked the proportion by moving the whole number over here. And by doing that, you have to change how you work with the percent. Yesterday, we would have just put the whole percent. If it was 36%, we would have put it in here. If it was 40.5%, we would have just written 40.5. But today, because we don't have that 100, that divide by 100, to take care of the fact that this percentage really is a decimal, you are going to have to convert all of your percentages to a decimal before you place them into the equation. So this was the first example. The statements are no different than the statements you were given yesterday. It's just all about how you place the numbers. So of still always identifies the whole number for us, 50. And when I go to place the percent 24, and I have to write it as a decimal, so that way when I figure out what part of 50 is 24%, I get the real answer of 12. If I did 24 times 50, my answer would be huge. We did this one together. So what number is 10% of 20? 20 is the whole because it's followed by of. 10%, I rewrite that by moving the decimal 2 places to the left as 0.1 or 0.10. I multiply and I get 2. You tried this one on your own. What number is 150% of 40? 40 is the whole because of precedes it. To turn 150% into a decimal, I move it 2 places to the left, so 1.5. You multiply and you get 60. But just like yesterday, we're not always solving for the part. We can also solve for the percent, and these problems actually have a couple more steps to them than when you solve for the part. And so 9.5 is what percent of 25? Of identifies the whole, which means 9.5 is the part because none of these numbers represent the percent, which is what we're finding. To get the percent variable alone, I have to divide each side by 25. A lot of you are doing a really goofy thing today. You were doing 25 divided by 9.5 instead of the other way around. It's 9.5 divided by 25. We work from the numerator down, and you get a decimal of 0.38. So you need to convert that back to the percent form to get the true percent, which is 38%. And so we did this one together. 3 is what percent of 600? Of tells me that 600 is the whole number. 3 is the part because I'm searching for the percent. So to get percent alone, I divide each side by 600, and I get 0.005. So to turn that back into a percent, I move it 2 places to the right, and I get 0.5%. You did this one on your own, and again, I had a lot of you doing 20 divided by 18, and you were getting this really weird number that was a repeating decimal. You shouldn't see those today, so if you're doing that, double check that you didn't copy incorrectly, or that you were doing the correct dividing, or you typed it into the calculator correctly. There's all these little places we can make just simple errors. But we divide each side by 20, and you get 0.9. You move the decimal 2 places to the right, and you get 90%. And finally, we can also solve for the whole. So 39 is 52% of what number? Since of and doesn't have a number, I know I'm searching for the whole number. Still need to turn that percent to a decimal. And you're going to divide each side by this decimal to get the whole number alone. And for some of you, this, like we always forget this, that when we divide by a number less than 1, it actually makes our final answer bigger. And that should make sense because if we're finding the whole number and this number is only about half of the whole number, then the whole number should be bigger than the part, which is 39. So we did this one together. We converted 80% to a decimal. 8 is the part of what means I'm looking for the whole number. Divide each side by 8/10, and you get 10 is the whole number. That 8 is 80% of 10. So 90 is 18% of what number? So 18% gets written as the decimal 0.18. 90 is the part, and when I divide each side, I get 500, and that makes sense if I say it out loud. 90 is 18% of 500. If I got a number that was like 90 is 18% of 12, that doesn't make any sense because 90 is just a small piece of this larger number. And then we have our real world application. That this equation is really behind the scenes when you go out to eat and you're calculating tax, tip, any of those things because they all involve a percent. So the first task was to find what is the meal tax or the food tax for whatever state this takes place in. And so the part is the tax, the percent is what we're trying to find, the food total is the whole number, and when you divide you get that decimal that we turn back in, so this has a sales tax of 6%. We can also use this equation to figure out how much of a tip we should leave a server based off of your food total. So the food total is again the whole, the percent turns into a decimal, and when you multiply those, you get that the tip for this particular visit should be $4.40. And we worked on this one together, so we were finding the sales tax for a different situation in a different state because meal tax really doesn't fluctuate from restaurant to restaurant. It's a state tax, so the whole is the cost for the food, the part is the tax cost. We divide the tax by the total food cost, and you get a decimal, and that decimal can be converted to the percent. And a lot of you said, so it's like 8 cents, and we got into that conversation about how, yes, it's 8 cents for every dollar, and so for New Hampshire, the meal tax is 9%. So if you go to McDonald's and you buy a menu off the dollar menu, or an item off the dollar menu, you would pay $1.09 or 109 because we have a 9% meal tax. So 9 cents on every dollar. And these people on this particular visit want to leave a tip of 18% on their food cost. So you take the food cost, you multiply it by the decimal form of the percent, and you get $3.33. So that is the percent equation at a glance.